David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, quadratic word problem. So if you've been following my videos, you know that we're now working on doing word problems that involve quadratic equations. And one of the most common type of word problem is objects that are thrown or shot into the air. So this word problem is another one of those. It's a variation on the rocket problem we did last. And so what I've done is I've wrote out the entire problem here. One piece of advice: it might be better to watch this video through without taking notes, just so you can keep watching it and follow along, make sure you understand. And then if you need notes, go back and make your notes. Okay, so let's get started. Here's the problem. A stone is thrown upwards into the air, and its height is given by this equation. So we've got somebody's chucking a stone up in the air, and you know that according to gravity, it's going to keep going up, but at some point the Earth's gravity is going to pull it back down, and it's going to hit the ground. So this is a classic parabola quadratic word problem. Okay, so here's our function, h of t. Remember, that means height as a function of time. And then here's my equation, minus 5t squared plus 30t plus 2. So we already know a few things about this parabola that confirm what the situation is. Minus 5. That means this parabola opens downward and the vertex is a max. And that makes sense because the stone's going to get thrown up. There's your max, and it's going to come back down. Okay, great. Then I defined your variables for you. T is time in seconds, we abbreviate sec. And h is height in meters, which we abbreviate m. Okay, so now we have our situation. Here's 3 questions that we're going to answer. The first one is, how high is the stone at 3 seconds? So we can figure that out. Second question is, what is the height at release? In other words, when they chuck that stone, how high is it first? And then the last one is, when is the stone 27 meters high? Okay, so we're going to answer all 3 of these questions. I'm going to leave this up and I'm going to do my math here one question at a time. Let's get started. How high is the stone at 3 seconds? So pause the video. See if you can do that. Okay, now let's see how you did. When is the stone, what is the height at 3 seconds? So 3 seconds is my time, and that's going to be my t. So all I have to do, and I'm going to use my notation, so h of 3, remember what that means is the height at 3 seconds, it's going to be minus 5 times 3 squared. I'm pulling it out of my equation right there, plus 30 times t, plus 30 times 3, and I have my plus 2 at the end. Let's get that out of the way. Now I'm just doing a bunch of math. H of 3 equals minus 5 times 3 squared. So 3 squared is 9 times negative 5 is going to be negative 45, plus 30 times 3 is 90 plus 2. So h of 3 is going to be 47. Are we done? Not quite. Word problem usually have units. So we know that t was seconds, h is height in meters, so I do need to put my meters there. So this is question number 1. Let's squeeze question number 2 right in here. What is the height at release? Okay, so pause the video for a minute and think about what that means and how you might solve it. And if you know how to solve it, work that through and see what you get. Okay, so the key critical thinking step here is similar to the last rocket problem that we did. Height at release means right when they let it go. So what's that time? That's t equals 0. Okay, so using our notation, h of 0, that's the height at time t equals 0, which is release. It's going to equal minus 5 times 0 squared plus 30 times 0 plus 2. So all I did is I plugged in my t equals 0, my 0 in for t in my equation, and I'm going to solve. And this one is super simple. these two terms are going to go to 0. So h of 0 equals 2. Remember, we have units, 2 meters. So what that means is that this object is not thrown from the ground. It's actually 2 meters high. And that kind of makes sense. That's a person releasing it like about there. It's a little over 6 feet. Okay, so we've done the first two problems. Let's take a look at the third one. Okay, when is the stone 27 meters high? Go ahead and pause the video and give that one a shot. Okay, so 27 meters high. So they're giving us the height and asking us to solve for the time. That's the when. So what we do is now we put in 27 for the height, and now we have to solve for the time. So this is my equation, minus 5t squared plus 30t plus 2. Okay? So to solve this, if you remember from your quadratic equations, we set one side equal to 0, and then we do what's necessary over here to find the value of t in this case. So I'm going to subtract 27 from each side. 0 equals minus 5t squared plus 30t. Minus 27 with a plus 2, that's going to be minus 25. Okay? So I'm noticing that I have a GCF in all of these terms. So I can either factor it out, or I can just divide through by that negative 5, because there's a negative 5 in all three of these. Dividing through makes it more simple, because when I divide this side by negative 5, it stays 0. So dividing this by negative 5 gives me t squared. Dividing this by negative 5 gives me minus 6. Dividing this by negative 5 gives me plus 5. Now that's a quadratic you could factor. 0 equals, what two numbers multiply to 5 that add to negative 6? That's t minus 1 times t minus 5. So that's going to, oh, I forgot my t. Maybe you caught that along the way. If you did, sharp eyes. Let's finish this up. This one is t minus 1 equals 0, t equals 1. And this one is t minus 5 equals 0, or t equals 5. Now we're not quite done. There's units with these also. This is 1 second, and this is 5 seconds. Okay, as an added bonus, we're going to take what we learned from our algebra here, and we solved these three questions, and we're going to throw it on a graph, because basically this stone follows the height of a parabola. We got all the information we need to graph this parabola. You're not being asked to do this in this question, but it's a very logical conclusion to everything that we've done so far. So let's take a look. Our seconds range from 1 to 5. So I'm just going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's going to capture everything we need. And I have two heights. I have a 2 meter height and I have a 47 meter height. So what I'm going to do is I'm going to grab 50 right there. And that's going to let me capture my 2 meters and my 47 meters. Okay? So, let's take a look. At 3 seconds, my stone is 47 meters high. So 3 seconds, I'm right about there. At 1 and 5 seconds, the stone is 27 meters high. So 27 is a little bit more than halfway. And then 5, it's also at 27. Finally, at release, it's 2 meters. So that's where it starts. It's right about there. So we know that's a point. And I could make a little tick mark going out to there to show 47. Finally, I know something else. I know that my vertex is going to be exactly halfway between the 1 and the 5. And that's also at 3 seconds, which happens to be our question from 1. So we know that that's the vertex. Now I can draw my parabola. There you go. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.